So, I welcome you to the lecture series on practical machine learning using Python. And today our topic is K-means algorithm. As you have seen that in the last lecture, I have I have illustrated what is unsupervised learning technique and what is clustering and the taxonomy of clustering techniques. So that lecture is very important. You will find the link in the description box below. Go through it if you have not already. So let's start today's class. So K-means is one of the famous partition clustering algorithm. So K-means belongs to what type of clustering algorithm? Partition clustering algorithm. Then it takes the input parameter K. And what is K? K is the number of clusters and it partitions a set of n objects into K clusters, so that the resulting intra-cluster similarity is high, but the inter-cluster similarity is low. So we are providing K as the number of clusters, and in our input data set, say we have n objects. So K-means algorithm will partition that n objects into K clusters. But considering the two properties, that is high intra-cluster property or similarity and low inter-cluster similarity. So that is our K-means algorithm. So let's discuss the steps involved in K-means algorithm. So you should note it down. It's very important. K-means algorithm we frequently use in building a machine learning model if it is an unsupervised one. So the steps involved in the K-means algorithm is that first step, select K points as initial centroids. And what is centroid? As I have illustrated in the last lecture, that centroid is our representative of one particular cluster, that is the center. Okay, so we first select K points as initial centroids. Then second step means repeat. What we need to repeat? We need to repeat this 3, 4, means form K cluster by assigning all points to the closest centroid. So you have say n objects and you are going to assign each object to one particular cluster, of course. Okay, as this is a case of hard clustering algorithm. Also, please note down that K means algorithm is a hard clustering algorithm, and hard means one point may belong to only one cluster. It cannot belong to two different clusters. Okay, so n data objects we are going to assign every point to a cluster which is closer to it than the others. Okay, so closest means centroid will be our target for assigning the data objects. Then recompute the centroid of each cluster. After we are finished with assigning the data objects to every cluster, then what we'll do? We again calculate centroid of every cluster, because this times maybe the centroid will be a different one, and these things will be repeatedly means executed, iterated until the centroids do not change. Means again we form K cluster by assigning all the points to the closest centroid, then the centroid being changed as we are recomputing it. Okay, so this 3, 4 will be repeated until the centroids do not change. This means one step or one moment you will see that the centroids are not further changed, and this is the moment exactly when you have to stop this K-means algorithm. Now look at this diagram. So first start number of K clusters. K means this is the flow chart actually. So this is the start button. You already know this. I think you all are aware with this flow chart, as we have learned this in our software engineering lectures. So start, then number of clusters K, then centroid. We are selecting initial centroids, then distance objects to centroid, then grouping based on the minimum distance. You should note it down that grouping is done on the basis of minimum distance. Then from this stage, we are coming to this stage, that is, this is a means condition checking step, whether no objects move or it is moving. If it is no object move is positive, means there is no further movement of the objects. This means what? We have already reached the peak of the clustering, means we have got the exact clustering of our data points. So we need to end the process of k-means clustering. If it is still moving, then again we come to here, means centroid will be evaluated again, then distance object through centroid, then grouping based on minimum distance. These things will be continued until no objects move. Okay, so that's it. That's the flowchart for k-means clustering algorithm. Well, you should note down that here we have an objective function that we always try to minimize, and that is known as squared error function. What is that? Squared error function. Because you will see in the objective function, we are squaring the distance of every point to the centroid of each cluster. And this equation is j is equal to, j goes from 1 to k, I goes from 1 to n, xij minus cj square. So this j goes from 1 to k means, suppose we are, or you are allocating k is equal to 3. So k is equal to 3 means there will be 3 clusters. So j 1, 2, 3. And say we have 10 objects, then n will be 10. So 1, 2 up to 10. So xi, suppose for the cluster 1, j is equal to 1, x1, 1 minus c1 whole square. So this distance will be calculated with respect to every clusters. Okay, so then we try to minimize this. Minimize it in shortest in easy meaning. You should understand only the main fact that we are calculating this distance and we are trying to minimize it, because allocation is done only on the basis of minimum distance from centroid to that data point. So that's the concept of K-means algorithm. And you have seen that distance measurements plays important or vital role in K-means algorithm. Why? Because you see that we calculate distance between each point of the data set to the every centroid initialized. And based on the values found, points are assigned to the centroid with the minimum distance. So distance calculation plays the vital role in the clustering algorithm. And as we know, the distance between 2 points can be computed with different techniques available. So our main aim is to pick up a proper technique for the from the available one. And I'm going to just give an overview of minimum distance means different distance matrix. I know that I have already discussed this different distance matrix, and they are means city blocks distance, then we have Euclidean distance, we have cosine distance, we have correlation distance. Okay, so I'm not going to discuss each of them now, as I have already discussed. If you ask me to discuss each of them, then obviously I will go through it once again. But as you know, this distance, Euclidean distance, is the means default one, so I am explaining it again. So Euclidean distance between 2 points A and B with k dimension is calculated as square root of j goes from 1 to k aj minus bj whole square. That is our Euclidean distance matrix. I have discussed what is K-means algorithm. So coming to the today's question. So first of all, you have to tell me what is K in K-means algorithm, and what do you understand by centroid in a K-means algorithm. And next question is that, tell me why distance matrix plays a vital role in K-means clustering algorithm. So that's it for today. Thank you.